systems, something that there was a very active and engaging discussion sort of offline outside of our monthly meeting about this with a handful of folks. So I don't know if Jeremy Avellino is joined, but we have him to thank for making this connection to the Holzrum group to talk about their system for mass timber solutions for buildings, low carbon solutions, something that we're very focused on, trying to get our world to be zero carbon. So we have Ilka, Steve, and Pat joining us today to present on their system. So they're going to give about a 15-minute presentation, and then they'll open it up to questions from the group. So I'll hand it off to them.
Good morning, everybody. Thanks so much for letting us come into your group. This is pretty cool. So Ilka and I are from Holzrum System. We're Philly-based design firm that's focused on wooden envelope strategies that can be brought to offsite manufacturing. And with us, a partner of ours is Pat Clark, one of the founders of Stoltz Timber Systems, and he's with us from Montana. They are producing, he's going to tell you more, and we're going to tell you more about them, but they are importing and also assembling and installing and designing with us mass timber systems, currently on an import strategy, but they are working towards being in production in a phased process starting in the spring next year. So, what happened with Stoltz and Holzrum is that Holzrum, we have this light framed, foam free, super low carbon assembly, full assembly core and shell system that we produce currently with Blueprint Robotics. We brought to them and kind of worked with them to tune up that light frame system. And Ilka and I, the other partner of Holzrum System, my brother, we always had the plan that we wanted to move mass timber into our wooden design quiver. We just weren't really sure exactly when, and we were just kind of waiting for it to organically happen. In the meantime, I had, and also Ilka has had, a long-term relationship with Pat and Stoltz Timber, because Ilka's doing energy modeling, and even before that, Pat and I had collaborated on some design projects, and we kind of hoped that we were going to get to work together at some point. So it happened, and now we handle all of their design work for their larger projects, and Pat is an awesome designer, so he's actually kind of helping us, figure out the right system. So that's sort of how Stoltz Timber and Holzrum System. And at this point, one more thing about that connection is that at this point, Holzrum System is not only designing their projects sort of West Coast, but we're now also representing and designing and managing any East Coast inquiries. So if there's anyone who's interested in projects on the East Coast with the system that we're going to show you, you can reach out to Ilka or I, and then we basically kind of work through what would be the right configuration and pros and cons. So, Pat, do you want to quick talk, or do you want to just kind of, what do you want to do?
Yeah, I can do a little introduction. So Stoltz Timber is a collaboration between myself. I have my former company was called Wooden House Supply, and for the last 10 years, we've been focusing on importing cross-laminated timber and its associated products, including wood fiber insulation from Europe. In 2011, we constructed the first cross-laminated timber building to be built in the USA. It was constructed right here in Whitefish, Montana. Since then, we formed a partnership with a company called F.H. Stoltz Land and Lumber, which is a 108-year-old sawmill in northwest Montana that owns 40,000 acres of its own timberland that they've been sustainably managing for that entire time period. And so my company, Wooden House Supply, and F.H. Stoltz came together, and we formed a new business called Stoltz Timber Systems. And the goal is to eventually wean ourselves off of the European import of products and start producing the timber right here at our facility in Montana for distribution around the U.S.
So you have this is a quick video on Stultz Timber, and then we'll move into some product overview.
It's a quick video on Pat's last project. It's like a minute long.
We kind of have this slide in there. It's in a way, it's almost sort of a leftover from our, our presentations on our light framed approach. Once we actually, Ilka and I we were an architect builder collaboration before we came Hultstrom System, and we've sort of over the last 7 or 8 years evolved from like completely passive house stick built, and then we started moving into like wall panels, and then eventually connected with Blueprint, and then they did a few projects for us before we became Hultstrom, and then we sort of started doing all of their single family homes with our assemblies. So we are strong believers, and we've sort of felt the difference in our own projects in cost and efficiency from moving our risk and many other pieces of this into the factory where it's possible. So that philosophy completely aligns with the CLT process. And actually we've found now already some new opportunities in this with CLT, simplification of some of the design elements. There's less parts. So there are some things about CLT that basically hit every one of these check boxes. And so we just kind of wanted to, I think everyone has seen this argument for offsite manufacturing. We just thought it was relevant to this talk because we're just seeing that it's sort of, each one of these points becomes, really brought home with some of the CLT process that we're going to show you.
Yeah,
Pat,
the same.
Same thing. I think these are all things that there's certainly no shortage of information on CLT. So I think everyone understands that right now. I think it's actually probably one of the most low carbon, just because of its storage potential, methods of building that's out there, especially if you're looking at it compared to like steel and concrete. But our focus mostly at Hultstrom is really single family and small multifamily projects. And the system that we are working with on Pat is really perfectly tuned to that, as opposed to some of the much larger, slab type approaches. So the product line that we're working with Stultz on is a solid. It's a system. So most CLT you see is a slab of some, it's either vertical or horizontal slab. That's typically what a CLT cross-laminated timber panel looks like from both European and North American companies. What's really cool about Stultz is that they have the system that is solid panels, which could be used primarily for exterior or load-bearing interior walls. And then they have a couple different they're like torsion block panels. So they have one called an open panel that has, you see the material on the bottom layer, that's a commodity item in Europe called 3-ply. It's sort of like a European plywood version, but it's all either, it's from the spruce typically or larch species. And it's a very tight, like it's almost like a mini CLT. And so what they do is they can come up with different configurations. They can actually glue up several layers of 3-ply to adjust for structural, acoustic, requirements. So that lamination, that thin skin that you see on the bottom of that panel, that can be increased in size. Typically comes in this, for an open panel, it comes in just over an inch. But it's basically a 3-ply panel that's been glued to a configuration of framing members. And then within that, they can put thermal insulation, they can put acoustic insulation. So that open panel that you're looking at could be used for roofs. It could be used for floor assemblies. It could be used for wall assembly if it made sense. It doesn't necessarily have to be that full grid. It could be just verticals. So it's really nimble. And what Ilka and I like about it is that in our design software, we really can get really flexible and try to figure out what is the most cost-effective panel or solid for the different parts of your project.
And then this is the element panel where there's just another 3-ply on top. So what it does is actually, it can reduce the height of the panel itself. And, Pat uses it mostly for floor assemblies, right?
Correct.
Actually, go back at one slide. So one of the things that we also didn't talk about is these are all metric sizes, but what's really amazing about these panels, and this is where Stolz is starting to really see some leverage for the use of element panels and also open panels for larger roof projects. So they can span, 6 meters, which is
20 feet roughly.
Yeah, 20 feet, but you can get these panels up to 35 or 37 feet long. So, as long as you have mid-span support, they can, right now, since it's import strategy, they can get panels that are up to 6 foot, 11 inches wide, and up to just almost 40 feet long. And that makes, and like I said, they can come with the therm insulation already in them, pull them out of the container. You can get an amazing high performance, super low carbon roof installed quite quickly. And we'll show you the total buildup in a second.
Yeah, so this is kind of an example on how to actually use those systems, how or what the buildup will look like in this case.
So in this case, the open panel is underneath a layer of universal dry, it's Styco universal dry wood fiber, which is about 2 3/8, and then there's a lath on top.
Let's talk about the components first, because we're gonna go into each layer.
Yeah, sorry. So they have open panel on the roof and open panels on the floors. The interior walls, we show open panels here, but more likely you can either do, you can do open panels, especially if you have some MEP, and then the exterior walls are solid panels, but you can also use the solid panels on the interior walls as well. So this roof buildup is awesome. It's the open it starts off at the bottom layer with a 3-ply, and then it has the grid of what they call KVH, which is an awesome product that we also don't have here, which is basically it's glue joined timbers. So you end up with really, really nominal straight timbers, very high grade at really great costs. And that's pretty much, there's different things you can put in that frame. So depending on your structural requirements, you could put glue lam or LVL, but typically the KVH is a very cost-effective way to achieve what you're looking for. And then the universal dry is a product that we use on our walls and our roof assemblies for our light framed as well. It's Holtram. Pat actually brought us to Styco, and that started our whole wall assembly actually, because he kind of turned us on to Styco years ago. And then we had formed a relationship with the distributor here, and then we brought them to Blueprint, and now Blueprint uses that product on all of our Holtram light frame systems. It's a great product, actually. That will go on manually after the panels are set, but it's tongue and grooved on 4 sides, on 4 edges. So it's watertight at a minimum, probably 2 or 3 in 12 pitch. It's basically watertight, but we put the membrane on it just as an extra security, vapor open WRB. And then of course, a rain screen venting. And then it finishes with a cover board, and then you can pretty much put anything else on top. The wall assembly is, Yeah, similar. Starts off with a solid CLT, 84 millimeter thick CLT. Comes in panels up to, typically it's vertically oriented, comes into panels up to about 6'10" wide, but that could fit in the container. And then there's a thermal package that is applied to the outside. And then it finishes off with the universal dry and a membrane and a rain screen. So it's pretty much the wall, except for it doesn't have the open panel.
And thermal bridge free.
All of this is completely thermal bridge free. Yeah. The floor panel, this is the open panel, pretty simple. It's a 27 millimeter 3-ply, can be oriented above or below, depending on what you want to do. And if you want to run some MEP, not that we always recommend putting this kind of MEP in a panel, but just to show you that it can be actually quite flexible if you needed some ductwork run in there, or if you had ductwork that was going to happen in the field afterwards, we can accommodate different levels of mechanicals. And then in this case, this was a project where the client was interested in applying another layer of 3-ply that would be a different finish. The 3-ply that typically comes on the Stultz panels is either spruce or larch. They're not doing this now, but they were talking about actually getting like an oak 3-ply finish. And what's kind of interesting about the 3-ply, you guys should really look into 3-ply. It's pretty awesome. It's coming. It's available through Stultz, but it's definitely making its way into the States. And what's cool is there are some companies that make all different types of finishes of this 3-ply. And again, that material can come in crazy formats. So you could stick it up as an acoustic ceiling, or finish on a wall, or ceiling, or not really a floor. But you can make cabinets out of it. So there's a lot of cool possibilities with that format. And this is showing, if again, an open wall strategy, which would mean it would be 3-ply on one side with the KVH members that are modeled and all the openings are in place. I think it's probably something that it depends on the project, because another thing that I wanted to mention that you can also do with these projects is, if you do a project with us and it makes more sense in the budget to do some of the non-load bearing interior partitions, they could also be framed still. So they could either be stick built on site, or they could be panelized and brought in as a hybrid situation. So in all of our projects, both Hultstrom's light framed and our collaborations with Stultz Timber, we require either that you pay a fee to have your MEP plan turned into a 3D model, or what we prefer is that you provide a 3D model of the MEP, which we bring into our single integrated model, and make sure that all clash detection and coordination has been accomplished like well before we even start any kind of production. There's some different strategies for running wiring. This shows just a couple options. There's also some options for running wiring on the wiring out on the outside of the CLT solid and coming in. But you just have to be careful about the air, the air barrier and the air tightness. So yeah, there's different ways. I mean, the main thing is you're really keeping most of that service out, just hitting the code compliant requirement for your services on the outside walls, which is true of our other walls as well. And then the other thing that's really exciting for Ilka and I, working with Pat and these guys, is that when you start to look at offsite manufacturing and you've already developed this model, you're always trying to figure out, well, what else can I get out of that model, and what else could I move to offsite manufacturing if it's going to be efficient. So this is a project that we're working on with Pat and his team to prototype a few different buildings that are going to be repeated 50 or 60 times. And so the idea is, why, if we're going to have all this potential 3-ply material CNC cut, why not look at what we call flat pack? So, if there are not necessarily cabinets, but potentially built-ins, chases, closets, whatever we think we might be able to integrate not only into the Hultstrom SIM model, which is our single integrated manufacturing model, but also into the whole production. So for instance, in Pat's, if we had some chase material that was on a project that's going to happen in Montana, we would design everything with the architect, and then Pat will coordinate with local CNC shops. So Pat would bring in the 3-ply material, and then we would provide all the files, and they could CNC mill, parts. So that the idea is that when the guys are erecting the CLT building, they're dropping pallets of the finished pack. And that means that when everything's sealed up and done, they're automatically ready to start putting up, running MEPs and starting to integrate some of the flat pack when it's time.
So yeah, kind of going back to that option or opportunity, it's only really possible because everything needs to be modeled up front. So we call it the single integrated manufacturing model. And we pretty much take all the different disciplines and marry everything into one single model. And then because this is the model that actually kind of produces machine files at the end, it's pretty much 100% right. So that is the reason why we can also then provide dimensions and drawings for things like kitchen cabinets and all of that. So because it's so accurate, we can kind of go back and feed out information to other contractors and other disciplines. And this just really kind of quick to show what just a shop drawing could look like. This is pretty much what would come out of our single integrated model. Fully integrated with MEP if that's what the client wants. This panel drawing. And then something pretty exciting that Stolze Timber started to really look into is roofs. Kind of funny, but a lot of people are looking for a really, really good roof solution for even bigger buildings. And we came up with this kind of assembly for a project in Montana, fully foam-free, kind of CLT option. And we did quite some studies with that. We energy modeled it, and we did a hygrothermal analysis with it. And it's actually starting to be very popular to look into that option.
Yeah, and actually that roof system that you were just that Ilko was just showing, when we priced it out against the specified roof that was it was sort of a TJI build-up roof, the Stolze roof system came in 15% cheaper with labor and material installation, and it basically was a super low carbon, same performance value.
Or a very large surface, so you can actually
14,000 square foot roof surface, and they're doing 4 of them. So it was pretty important that they really, capture that savings, but also move what was really just a high performance, but not really sort of a low carbon assembly. And now they're looking at this for not just those buildings, but also for 60 smaller buildings.
And here there's some pictures from Pat's installations.
Pat, you want to talk about some of the install?
Oh, sure. Yeah, I guess one of the critical, or maybe the best selling point for builders, developers, is the speed of build for the system. Like in the bottom left there, you see a small, I don't know, it was like a 2,400 square foot guest house that we constructed. The panels for that building went up in 6 hours. So the clients were on their way to work at 8 o'clock in the morning, and there was just an empty foundation. And when they returned in the evening, the whole building was completely stood up. So that's, depending on the time of year, that's a big deal for sure. And then, there's a little bit of, say, a little learning curve with the fact that now you're handling, instead of handling little 2x4 sticks or little 4 foot by 8 foot sheets of plywood, now you're handling very large elements. So you sort of have to change your thinking into crane construction. So, the site itself is almost set up more like a commercial building, even if it's residential. because you have larger panels, larger beams, big, heavy, unwieldy objects. So you utilize a crane for 90% of the construction process. But since everything is completely pre-cut off-site at the factory, everything is numbered, labeled. We know the weights. We know exactly where to pick the panel. So the process goes pretty seamlessly. Like this building that you're looking at here in the bottom, that structure went up in 5 days. It's a 2,600 square foot garage guest house.
Yeah, so this is pretty much it from our side. Do you have anything you want us to go back to or questions?
Yeah.
Yeah, there are a few questions that popped up in the chat. Thank you so much for this presentation. It was so great to see. And there's one question, and Pat, you responded, but about the thermal layer material and how it's vented. Do you want to speak a little bit more to that, to the wood fiber installation or insulation? Sorry.
Steve, do you want that, or do you want me to do that?
Yeah, I'll take that. So on the walls, the outer layer and the thermal break on both our light framed and what Pat's doing with Stultz is a universal dry Styco wood fiber product, and it needs to breathe. You can't put a sheathing. You shouldn't put a sheathing up directly against it. If you put a plywood in contact with it, it's better, but you really shouldn't put like a Perm 5 OSB layer directly in contact with it. That's the whole purpose of it, is that's what makes the assembly vapor open, with very open perm towards the outside of the wall. So we have that in our light framed, and Pat has that in his system. So that's true on the roofs and the walls of everything we do together and separately. So that means that all of our assemblies need to be vented. And the venting, what typically happens on light framed and CLT buildings that we do is that outside of the Styco layer, we use a 60 mil. They also have a 40 mil. So, you still would have a pretty decent thermal break at 40 mil. And so I know companies like Benson Wood and a couple other companies, they use a 40 mil. We like the 60 mil. It has a little bit better dew point, offset. And it's still a really nice product to work with. And of course, it just adds a little bit more R for us. So, but outside of that wood fiber, what you do is you have to align your batten, your first course of batten, if you're doing a double bat, like a lattice 2-layer or single, you just have to align your battens, and your battens get a panel screw into the CLT. They basically, or into the KVH. So there's the CLT, and then there's that KVH member on the outside, which gets insulation inside between those verticals. And then you just need to align your panel screw for whatever your rain screen is. It's pretty much just like any other passive house. There's going to be a rain screen. But when you're using wood fiber, you got to have it, whether it's a roof or walls, you got to have venting. Usually 3/4 inch is fine. But depending on where you are, you might bump that up. And that's when we do the hydrothermal analysis. Like, I think we determined we needed an 1.5 inches was going to work for us for the project that we showed you in Montana.
But also, I wanted to add to that, Steve. I think Steve Krug was saying, what is the material? So a brief description of what wood fiber insulation is. It's a product that at the sawmill facilities, when they're producing boards or timbers, they end up with a lot of chips. In a modern sawmill, when the round log goes through the sawmill, they take chips off of the outside of the tree first, and those saw chips are run through a refining process that I kind of jokingly say is kind of like making cotton candy. So you have this cyclone spinning, and the chip is in the cotton candy maker, and it's 99.4% wood and 0.6% polyurethane non-toxic resin that helps bind the fibers together. And they introduce steam to the process, which melts the wood fiber. It brings out the natural lignin glues in the wood fiber, and all of the fibers sort of coat each other and they bind together like this. And then under steam, they apply pressure, and that forms a continuous mat of insulation. Depending on how much steam, how much heat, and how much pressure, creates variable densities in the wood fiber insulation so that you can utilize it for exterior walls, roof assemblies, floor assemblies, acoustic partitions between rooms. So it's a very flexible product in its utilization in buildings. And at the end of the day, it's 99.4% pure wood. So it's a great alternative to anybody who's looking for a solution that's not foam-based or petroleum-based.
I'm looking at these chat comments. Should we just go ahead and see if we can answer a couple of those, Bunny? Is that all right? Or
yeah, I think it would be great. We have time for like one or two.
Okay, Ilka, do you want to take the one about the old building renovation, or?
I'm just kind of finding my chat box here.
Yeah, I think Daphne was asking if there have been applications of your system in existing buildings or opportunities to hybridize the system with existing structure.
Well, that's definitely something that we've been thinking about and really want to make work and think it will work, but we have not done it yet. So, but we see a huge opportunity on in, you know, replacing kind of foam-based panels with a system like this, and we strongly believe it's going to work, but we haven't done it.
Yeah, one of the things that we like about the Stultz approach, as rather than just sort of the straight CLT, is it's that flexibility with those layers and those different members. So, you know, the 3-ply can come in almost any thickness you want. So depending on what you're trying to achieve, we're actually working on some strategies that would be a thermal package that could be a retrofit option. And we think that's a gigantic need right now, not only for old buildings, but for non-CLT buildings as well. So we're working with Stultz right now on a system that would be basically a delivery of a thermal, foam-free thermal panel. And this, you know, the products, these 3-ply products combined with KVH and these awesome wood fiber materials, we think we're gonna solve that puzzle through the right configuration of these. And then the thing that also makes it all kind of work is that you have all these different layers and these different parts, and then you put that into the design software, and now you're just absolutely flexible, right? You know, you're not just talking about ordering a panel that has a bunch of studs 2 foot on or 16 inches on center, 2 foot on center. You're talking about a very custom but clean and lean kind of grid that just needs to basically transfer your load of your facade hanging outside to whatever your structure is. And so, you know, if you know what that is, then you can design that framework really, you know, it's just CNC machines. They don't care how many parts are the same size. They just want to file. So that's kind of what we're trying to marry together. And it's pretty exciting.
Yeah, you'll have to keep us posted on that. It sounds really exciting.
Yeah.
Maybe one more question.
Cost, maybe. Everyone's always curious about cost.
Yeah,
Pat, do you want to talk about that?
Yeah, let's see. The one says, Pat, what are cost differences for SIP roof versus CLT? Does CLT make economic sense?
I don't really know a lot about, I mean, I haven't kept up on SIP panel costs, but generally speaking, what we tell folks is, so the structural thermal envelope, which would consist of all the floors, all the exterior walls, interior walls, all supporting beams, roof assembly, all the specialty hardware. There's a lot of specialty hardware that goes into putting these together. All the sealant tapes to make it airtight, specialty gaskets, acoustic materials, all of the 3-ply panel products that we utilize for like window and door bucks. So literally a ready to assemble kit of parts that provide your structural thermal envelope. raised on your foundation. So the contractor is providing a foundation. We show up with the package and we raise it on your building site. It's usually about $85 per square foot. And, you know, in a few days, you have all of the structural thermal components for the entire building.
Yeah.
We feel that that's pretty cost competitive in most U.S. markets, especially when you include the speed of build, the energy performance of the building.
Yeah, I mean, I have done a ton of SIP buildings. You know, my background is timber frame design and construction, and so I've been doing SIP buildings since the early 90s, and they're cost effective, but they're also a tremendous carbon load, like ridiculous carbon load, and they scare me. They started to scare me when I started to learn more about passive house with vapor control, because there's not really a strategy. You basically have a very, very closed, permeable closed skin that you're trying to achieve at airtightness. And the problem is that it's actually kind of difficult to achieve airtightness with a SIP building, especially if it's like around a timber frame building. So if you have a standalone SIP building, it's, I think, maybe a little easier, but it's challenging to get it taped correctly. And the problem is you don't really have vapor transport, except for the areas that are not, that have infiltration or exfiltration. And along that infiltration, there's moisture. And, you know, there are lots of cases. My brother has a case on his roof he just replaced this year, where the moisture over time accumulated into, because you still have structural members in a SIP building, whether you have a timber frame holding it up or you have ribs that are kind of, you know, at a ridge or between SIP panels. They're structural members, and they're thermal bridging because they're not foam on both sides of them, for one thing. But the main thing is that they're transport for moisture. And so you can have this weird thing that can happen with dew point that's just generally not really controlled. In theory, it's awesome to have this massive piece of foam exterior insulation that's sort of keeping dew point off of everything. But in practice, what I found for many years is that it's very challenging to prevent that. And then, of course, once Ilk and I found out or learned more and more about the carbon footprints of the sort of the passive house with foam approach, which is so prevalent, we just made a really hard line decision that we wanted to move away from it. And that's one of the main reasons that we started really to bring in the wood fiber. There are people that are looking at SIPs with wood fiber though, which is really cool. They just have to manage the vapor open part, because an OSB skin on both sides, which is what a SIP panel is, doesn't necessarily work with wood fiber. It's a little too tight. So they're looking at different ways of doing it, but I know it's happening. You know, they're looking at it right now in the States, but it's not going to be cheap to do that. So.
Well, Ilka, Steve, and Pat, thank you so much. This is very informative. Again, for everyone who's on the call, we're recording this. So we'll share this out after the meeting. Our Vimeo account, you know, is getting picked up nationally as well. So you should get some good exposure on this for you all.